And now I want to introduce Krista Asanovich to give us an update on the state of RISC-V.
All right, it's great to be here. Back in Zurich, I was here a couple of years ago. Saw the amazing number of chips and tape outs at Luca's lab, which is fantastic to see. So I just wanted today, this morning, go over the State of the Union. What we usually do here is talk about some thoughts and themes that came up over the last 6 months or so, and also a bit more on the strategy of the ISA development. There's going to be a lot more detailed talks about down in the depths of all the individual components, but I want to give kind of more of a broad, where are we going? So first of all, what is RISC-V? So Callista said you all knew, so here's the test. So what is it? Well, it's high-quality, license-free, royalty-free ISA, originally from Berkeley. Standards now maintained by the foundation, suitable for everything. People ask me, what's it good for? The answer is everything, eventually. There's a lot of cores out there, big uptake, I'll talk more about that, and a growing software ecosystem, and it's still a work in progress. I always like to go back and look at the timeline, and the axis here keeps getting denser and denser as we add more years on. We're now 9 years into the project, so next year is a 10-year birthday party. I don't know quite how we're going to do that, but there will be a 10-year birthday party for RISC-V, right? So we're going to do that. So we started back in 2010. Let's tape out. I'm just going to skip through. You've probably seen all this. 2014 was the big date in RISC-V when we really pushed things out of hot chips wearing these T-shirts. That's when the big industry push started. Then we incorporated the foundation in 2015. Then we had these major announcements. NVIDIA announcing they're going to use the GPU 2016. The first commercial cores appeared 2016. First commercial SoC, end of 2016. Then Western Digital made the big announcement about switching over to RISC-V. Still waiting for the next big company to announce they're switching to RISC-V. So I'm applying pressure behind the scenes. There's a lot of companies who are planning to do this, but haven't done this yet. The first Linux SoC came out from Sci-Fi beginning of last year. And we had the first big summit. That was over 1,000 people. And that's really kind of RISC-V arriving, I think. So we sort of made this migration from a Berkeley academic project out to a massive industry force at this point in time. And you're out here in Zurich. And one of the big things I want to sort of let us celebrate is we actually ratified the base specs, the privileged specs now. I'll talk a bit more about that. That's a big milestone. So here we are in Zurich. So to reiterate what Callista was saying, what's different about RISC-V? It's just another RISC. It's kind of a boring RISC in many ways. But we made it very simple, and that took a lot of work. We tried to keep it clean, and one of the big features is make it modular, so it would support extensibility. And we wanted to keep it stable because it's an open source ISA, we have no motivation to keep changing it, so we can keep charging you more for the next version, right? Everybody likes stability, and that's what we're trying to promote in RISC-V land. Also, the community is designing it, right? So this is the big effort of everybody working together to develop this. So the ecosystem, people get a bit confused sometimes about the RISC-V ecosystem. So how does this thing work? Well, the foundation sits at the middle and provides the specifications. This is the standard for the ISA, go to model, compliance suites. And that's really all the foundation has to do, and that's a lot of work to make the ecosystem function. And then above this, you have the software, and below this, you have the hardware. And the beauty is that with a standard interface, all the hardware can use all the software. Well, that's the theory. Okay, and on the hardware side, we have an open spec, and people think RISC-V is an open source processor. That's just wrong. RISC-V is an open spec, but because it's an open spec, you can have open source cores. And Luca talked a lot about the pulp cores. There's a bunch of those, but there's a whole slew of open source cores out there from all around the globe, different people building RISC-V open source cores. But that's not all. You also have commercial cores. So you have commercially supported verified cores from a bunch of providers. And what I like to say is at this point, RISC-V already has more commercial core providers than any other ISA in history, right? There's more places you can go get a commercial softcode now than there's ever been for any other ISA. And the other thing is, because it's an open spec, companies are able to build their own core without taking out an architectural license. So for example, NVIDIA is using it on their GPUs, they're building their own core, and that's perfectly fine. So there's many different ways of getting a core for your project, and that's one of the big advantages of RISC-V. And the other thing is the software. On the software side, the open source community loves the idea of RISC-V, and they've really been running around and helping build up all the ecosystem we need around RISC-V. I've been very amazed and really grateful for all the work everybody's done to bring up things like GCC, Linux, all the other necessary open source tools. But it's not only open source software. There's open source there's commercial software too. So now what you're seeing in response to the uptake in industry, people are used to using a commercial tool like Lauterbach, Secker, etc. These folks are now asking for RISC-V tooling, and the companies are responding with products in that space. So RISC-V is getting very strongly supported in commercial software as well. So the important thing is the spec is this interface between the hardware providers and software providers. It lets somebody come and innovate at the hardware level, but take advantage of all the existing software. They don't have to boil the ocean again just to try out some new idea. They can reuse most of what's out there. So why is RISC-V so popular? It is popular, so why is it so popular? And I think sometimes engineers get a bit down in the weeds, don't see the forest for the trees. It's not happening because RISC-V is 10% faster, 30% lower power, although any given implementation may be. The reason is the business model has changed. And this is really why we're having this big effect on the industry. So previously, you first picked a vendor, and then you got their ISA, and then you're kind of stuck. You're locked in. For RISC-V, things change around. Now you first pick the ISA, I'm going to use RISC-V. Then you have freedom of picking where those cores come from. Is it commercial? Is it open source? Is it one homegrown core that you build yourself? So giving that freedom is really what's exciting the industry and getting them behind it. And also the fact that because everybody has an architectural license, you can go add stuff without asking permission and innovate on your own. Now, whatever's missing, and because of this big change in the business model, whatever is missing in terms of features or PPA is going to get fixed. There is so much momentum and energy being put into RISC-V. You'll see, that's kind of one of the themes of the talk, all the various things that we need to work on to complete RISC-V for all these different uses. So everything is going to get fixed. So the goal, we've been saying this for a long time, and it's become less and less funny. Become the industry standardized, say, for all computing devices. In a few years, this will be like, yeah, of course it is. It's like Ethernet, the standard network for everything. Like that's what RISC-V is going to be. So how are things going? Well, just some of the sort of sense things over the last few months, things that have been I've been noticing. So RISC-V is really at the heart of open source hardware. And this may seem kind of obvious, but I think what you're seeing is all these new consortia who are around open source IP. And so in Europe, you have FOSSI. China, there's a RISC-V alliance there around open IP. The CHIPS Alliance in the US. We just heard about open hardware here in Europe too. And with a lot of companies being involved in these consortia. So there's a big upswing in interest in open source hardware. And yes, so open source hardware needs open source cores, and open source cores need open specs. So this is partly why RISC-V is playing a role here. But I think it's a bit bigger than that, is the success of RISC-V in commercial adoption is really opening the eyes in the hardware industry to this open source hardware idea is maybe not that crazy, right? And so you're now seeing companies saying, well, if RISC-V works, maybe we can use it elsewhere. So this is spreading out from not just the cores, but to other parts of the hardware. And it's not only academics and hobbyists now who are thinking about open source hardware IP. You see major companies, like you see the parties involved in the various consortia here. These are serious large companies who are getting involved in open source hardware IP. And I really think RISC-V is driving this, partly because you need a processor for most of these chips, but it's also the success that RISC-V has had that is opening people's eyes. Maybe we can reapply that idea to other parts of the hardware industry. Another theme I think is now, RISC-V is now an everyday design choice. And what I mean by that is, you go out in industry and you compete for sockets on chips, and you see that RISC-V is now winning a lot of sockets in the embedded IoT space. People are choosing to use RISC-V in commercial projects. This year, you expect to see production start to ramp up. So you're going to see millions of SoCs with RISC-V cores on this year, by sort of most people's estimates. One thing from Sci-Fi, we announced over 100 design wins of RISC-V IP cores. So that's over 100 sockets on various SoCs of different RISC-V IP already. And so this is what I mean is, you don't get fired for choosing RISC-V, right? So, in a few years, you might get fired if you don't choose RISC-V, right? We haven't quite got there yet, but we'll see how that goes, right? So why do you do this non-standard thing, right? Okay, so these are kind of themes. Open source hardware is becoming a thing, I think driven by the success of RISC-V and aided by the fact RISC-V is there. And also RISC-V is becoming something people it's in the mix of things you choose from in a commercial project these days. So let's talk a bit about the ISA standards and roadmap. This is really, the meat of the foundation work, what we have to do, all the hard work we have to do. So first thing, I just want to celebrate the fact that we finally ratified the original specs from Berkeley. So this has been a long, hard struggle, but now RV32 IMF2QC and RV64 IMFDQC are now ratified. The A extension has one tiny issue to resolve, which I hope we can work on this week. Oh yeah, one thing I want to say, as I go through talks about the ISA and the roadmap, the goal here is to really seed some thoughts and get you thinking about stuff. So during the next few days, please talk, mingle, interact with everybody, and let's propagate these ideas. We're all here face to face, a great opportunity to get higher bandwidth on working through some of these technical issues. That's really why I'm going through some of these. The memory model was ratified, the privilege architecture was ratified. And so this is the foundation of the foundation, right? So that's in place now. So we have base ISA, it's all done, the privileged architecture is all done, and what it now means is we have a lot of legacy. So, and we have to build on top of this the future standards, but this is really a very, very important milestone that we hit early this year. Now, the thing about RISC-V is designed to be extended with new modules. So what do we do next? Remind people about, how do we prioritize future ISA standards? And again, this is feedback. Tell people what you need, come talk to us, come work with us on. The community should drive the roadmap. But some of the things to be aware of is in prioritizing this, is anybody going to really build it? You may have a cute widget you want to put in as a standard, but is anybody actually going to build that? Will it increase design wins? This factors into would anybody build this? Does it fill a hole? Does it standardize something we're doing incompatibly today? Does more than one member care about it? Are the people able and willing to work on this part of the spec? So these are all questions. If you're wondering why do we choose to do some things and choose not to do others, these are some of the factors that go into it. And who's we? We is all of us. Collectively, where does the energy end up going? And these are the reasons why some things happen and some things don't. One other topic I like to reiterate to people is fragmentation versus diversity. So the goal of RISC-V was to support extensive customization. Everybody's like, well, doesn't that mean you're just going to get a terribly fragmented ISA, everybody doing different things everywhere else? And I think what's important to understand is this big difference. So fragmentation is a bad thing. Fragmentation is when you're doing the same thing two different ways for no good reason. So this is my favorite example, right? So steering wheel on the left, steering wheel on the right. I mean, it doesn't really matter except people chose differently. And now we have twice as much, twice as many SKUs in the car industry as we needed, right? So this is just wasted human effort. Like humanity suffers because of this decision, right? To do things two ways. But sometimes you need diversity, right? So, if you only go across town for a few miles, a bicycle is a great thing to do, right? If you need to carry 500 people 5,000 miles, jumbo jet is the right thing to do. So different workloads need diverse solutions. So this is okay. When you're solving different problems, it's okay to have different techniques. But when you're solving the same problem, try and do it the same way, right, to get more reuse. So with that in mind, I just want to recap from previously what we set up as the priorities for 2019. Want to work on implementations of software stacks or the fast interrupts, vectors, and hypervisor, and those are all making good progress. Work on the Unix platform standard, embedded ABI. I'm working on the embedded, and so where I sort of framed this previously, we initially worked a bit hard on kicking off the Linux effort because we knew that had a longer latency, longer time to get everything going. And we have been this year focusing more on the embedded space, which is where a lot of RISC-V activity is going on, things like code size. But one thing I'll also say is we need a lot more people being active in standards. The community is growing. We're getting more and more companies as members. I'm not seeing the same growth in number of people stepping up to be task chairs, vice chairs, or actually on the calls. And so I would like to see the same kind of chart of growth of people participating in the standards activities. The thing about standards, design is easy and fun. Standards are hard work. So things we have to do, we have to debate all the fine technical details, separate facts from opinions, evaluate the implications for hardware and software, understand commercial realities. Now we have to worry about backwards compatibility. Getting rid of saying no. It's easy to have three options and say there's a switch that selects between the three of them. That gets back to fragmentation and avoiding it, right? and reaching consensus. So one thing is democracy is definitely a poor correlation to getting consensus. We don't want to have to vote on things. We want everybody to agree on this is the right way forward. So hammering things out till the point we get consensus is important. That's what we like to do. So this all needs work, and we need more skilled participation. There's many more members. There's many more big companies joining. We'd like to see more participation, please. So some of the things you can work on, the embedded ABI, we've been pushing this through. The original ABI was developed for Unix platforms. I realized we needed to change this to make it better fit for embedded space, also to make it more portable across the different flavors of embedded. So embedded, there's a great deal of diversity. You highly want to tune your design for each use case. And so embedded ABI is one example of doing that. The proposal is up there. We're going to need some help running, and I've just noticed this morning there was some email. Great people have been running experiments on different versions of this, and that's the kind of help we really could use. People providing engineer time to work on these things. Putting the floats in the X registers. This is another concept that we need to build out. Improving embedded code size. This is a big issue. We've sort of been putting the steps in place to get to work on this, including the embedded ABI, including ZF and X. Now we can start working on possibly new instruction extensions to help with code size. Again, this is going to need a lot of effort from the especially compiler authors to work with us on this. But it turns out in code size, there's a lot of other issues, library design, ABI design, that also play in. So this is going to be starting up. So please join this. Security. One comment I have here is RISC-V is a natural focus of security research, but a lot of questions are, how do you use RISC-V now to do security now, right? So it's great that people are doing research, but how do I build a secure system now? And the last summit, we kicked off a bunch of discussions around building platform profiles with security in, and we started the discussions. We need to kind of finish them and start producing collateral for the community to understand how to use RISC-V. We did actually design, one of the issues here is we designed RISC-V to be very flexible and provide composable security primitives, whereas most people are used to a prepackaged solution that's designed for one threat model, and then they try and use it with all these other threat models and it breaks. So we didn't want to do that, so we wanted to provide a set of primitives you can compose. However, we do need to give people the recipe book so they understand how to put these things together to attack certain threat models. Software, great progress. Talked a lot about this. In reality, we need a lot more work in RISC-V software, and people have been talking about somehow getting the investment, shared investment across everybody to build out the software stack. And if you have ideas of funding sources, I know there's several efforts underway on really building out a shared community that's working on all the shared software that the whole community needs, and how we get funding and engineering time behind those efforts. I just want to sort of finish up with some looking ahead a little bit, so planning where I think we need to go. So some predictions for next year, 2020. I think what you're going to see is some significant investments being made by various parties in higher-end RISC-V cores. You're going to see people looking at server, looking at mobile, also in automotive space. Now, the problem there is that there is a lot of stuff needed to support those kinds of engines, the ecosystem. So work on the hypervisor that's been ongoing, and I'm glad to see we have initial QEMU implementations out there. Vectors, similarly, there's a lot of progress. Security, things like power management, server platform profile, and we already mentioned functional safety as another standing committee that the committee's putting up. But I think you're going to see 2020. These are starting to appear on people's ideas, roadmaps, startups, whatever, working in this space. So higher end stuff is coming, and we need to start at the foundation, preparing the foundations for that. Another prediction, this is one that sometimes the people, they always put RISC-V against the obvious competitor. And I think what people losing track of, when we originally designed RISC-V, the idea was, all your cores belong to us. So everything's going to be RISC-V, not just the general purpose cores. So I think next year you're going to start seeing, people using RISC-V to replace more of the other cores on chips as well. So a more diverse range of core types. This is also going to be interesting in terms of standardization, because this is obviously a quite diverse crowd of cores, and what level of standardization we're going to have in this space is going to be interesting for us to deal with. But that's something I also see coming up 2020. Okay, just to wrap up, to summarize, great news is the core standards are ratified. That's like, to me, one of the highlights of the year already so far. It's like Christmas in March or whatever when this finally went through. Yeah. The acceptance and adoption of RISC-V has just been incredible this year. The community is growing and growing. Just wonderful to see how many different organizations and groups are rallying around RISC-V. The software ecosystem is filling out rapidly, and the standards effort, we are filling in the gaps, but there's still a lot of work to do. So thanks for all the hard work, and I'm looking forward to even more hard work from everybody. Okay, thanks.